Okay, this is the video for section 4.3. This covers questions 22 through 30 on worksheet 7 and wraps up this first assignment packet. Okay, so section 4.3 is on rational functions. And if you were ever able to just kind of look at some of the different kinds of rational functions, these are some of the examples that you might see. You got one here that's got comes along, it's got a bump in the middle and comes back down. You got these where you've got the two different parts here and here. You've got this one that's actually broken up into three different parts. It kind of looks like that. Okay. What's consistent with all of these is that they will have what are called asymptotes. And I think we've done a little bit with asymptotes before. Okay, so we're going to explore only two types of the asymptotes. We're going to look at when an asymptote is horizontal or when it's vertical. The other thing we're going to do with these is we're going to look at domain and range, so that we can see a little bit about the parameters that form each one of these rational functions. So the first group of problems that you have, which would be questions 22 through 25, they give you a function and all they're asking you to do is determine the domain. So I've got a little bit here on this sheet. The domain for a particular function exists everywhere the function has solutions. Okay, so what we're trying to do is we're trying to look at where does it not have solutions. Okay, those places where it doesn't have solutions are called exceptions. And in a rational function, that will only occur when the denominator becomes 0. So we're looking for the numbers that make the denominator equal to 0. Those will be our exceptions to our domain. Most polynomial functions, the domain is just the set of all real numbers. We will have, in some cases, you don't have to have an exception if it's rational, okay, but sometimes you will as well. So here's what I'm going to do. I've got number 24 and 25 down below. We're going to talk about how you set those up, determine them, and then how do you write the domain based on that. Okay, so on number 24, and all we need to worry about is the denominator. The numerator tells us nothing about the domain. So if f of x equals x divided by x to the fourth minus 1, I want to take x to the fourth minus 1, and I want to set it equal to 0. Okay, now solving that, I would first take that left side and factor it. This is the difference of squares, so it breaks up into x squared minus 1 and x squared plus 1. But the x squared minus 1 is also the difference of squares. So it's x minus 1, x plus 1. The second binomial, x squared plus 1, does not factor. Okay? And if you use the square root method and solve, you're only going to get imaginary answers. So I can exclude that part of it as terms of my exceptions to my domain. When you set each one of these equal to 0, I get x equals 1 and x equals negative 1. Let me scoot that up just a little bit more. And so based upon that, those are my exceptions. So based on that, my domain is, and there are different ways you can write this, okay? All real numbers except x equals plus or minus 1. That's one way you could write it. I'll show you a different way on this next one here. Okay. On number 25, again, start by taking the denominator and set it equal to 0. Okay. In this example, the 3 out in front can be just dropped because 3 will never equal 0, so I don't need to consider that. So I'm going to cancel out the 3. If there was a variable attached to it, like 3x, then I would need to set it equal to 0. But the x squared plus 4x plus 4, just like the previous problem, is factorable. It breaks up into x plus 2 and x plus 2 again. Okay? Now, if you chose to take the 3 and distribute it through and then factor, you would still get the same things in terms of your final solution. I just chose to go ahead and eliminate it at the beginning since it wouldn't have a bearing on my answer. Okay? When you take each one of these and set them equal to 0, basically I get one solution that's going to be repeated. I get x equals 2. Okay, now, so that is the only number that will not create a solution. So that would be my exception to my domain. So my domain this time, and I'm going to write it just a different way. Okay, actually, I'll show you a couple different ways. Okay, from negative infinity to negative 2, unioned with negative 2 to positive infinity. So there's the set of numbers that would represent that solution, or that's called interval solution, or the domain is the set of all x values such that x does not equal to negative 2. Okay? Also says the same thing. All real numbers except negative 2. Okay? So the other two problems are broken down a little bit easier for you, but the process is the same. Set the denominator equals 0, whether you have one exception, two exceptions, you can have as many as you want. Okay? But you find those exceptions and use that to write your domain statement. Okay? Questions 26 and 27, they give you a picture of a rational function. Okay, so in these examples, I'm going to use number 27 as an example here. Okay, now, first thing it does is it says, find the domain and range. Okay, so domain is where as you go left to right, range is you go from bottom to top. Is there anywhere that the graph does not go? Okay, so for domain, I see this dotted line at -1 and another one at +1. Those are asymptotes, and the graph does not and will not touch or cross an asymptote, okay? A vertical asymptote, okay? Now, so that means that those are going to be exceptions where the graph doesn't exist. So I'm going to say my graph is, this is going to be the shortest method here, it's the set of x values such that x does not equal plus or minus 1. Okay, there's your domain. Okay. Now, for your range, going from the bottom to the top, I notice a dotted line here on the x-axis. There's a horizontal asymptote on the x-axis. That's y equals 0. Okay, but this middle section of the graph crosses that asymptote. Okay, so a horizontal one can. A vertical one won't. So, but in that regard, though, okay, then I can say that for a range, it's going to be just all reals. There is no place that this graph will not go vertically. So horizontally, we got a couple exceptions. Vertical, we do not. Okay, so that's part A, the domain and range. Okay, intercepts. Intercepts, again, remember, there are places where they cross either the x or the y-axis. And because of the asymptotes on those outside pieces, there aren't any, but there's one in the middle. In the middle, I have an intercept at 0, 0. Okay, and then horizontal and vertical asymptotes. Remember how you write horizontal lines. Okay, so for a horizontal asymptote is a horizontal line. That means it's a y equals. So horizontal asymptote at y equals 0. Vertical asymptote is x equals -1 and x equals +1. Now again, please write those out separately. Don't just put -1 comma +1, because these are equations of lines, and we want to list each one of those lines separately. If it's horizontal, it's y equals. If it's vertical, it's x equals. Okay, but you're going to be doing the same 4 parts to the question that's on number 26 to just the left. Okay, so that's how you do 26 and 27. Okay, in the last group, we're doing similar things, but we're doing it from an equation only, no graph. Now, if you wanted to graph it, you could. Okay, and I'm not sure if you're going to be able to see it or not, but I'm going to go ahead and do that for 29. It's not as bad to graph. So I'm going to go to y equals, and I'm going to type in hold on, just let me clean a couple things here. So I've got 4x to the 5th divided by x to the 3rd minus 1. And I'm going to graph that. Okay. Okay. So it looks like that when you get done graphing. Okay. It is because of the x to the 5th on top of it, you've got kind of an odd, you have an odd function, okay? And so that's why you see the 2 tails going in opposite directions, okay? So left tail goes up, right tail goes down, okay? Now, okay, so with that in mind then, that's what I'm going to looking at. Now, let's go through what the questions are asking me to do, okay? So first of all, are there any, or what's the domain? So if you remember the first group of questions, to find the domain, okay, you take the denominator, set it equal to 0. Okay, now, this is the difference of 2 cubes. Okay, the difference of cubes. Now, that's going to factor into x minus 1 when you take the cube roots. And remember how we square the first one and then multiply, okay? Take my word for it here. You get x squared plus x plus 1 as the remaining factor. Now, this only yields, if you plug it in the quadratic formula, this only yields imaginary solutions. Okay, so I don't need to mess with that. Okay, but what this tells me is that I have a, when you set x minus 1 equal to 0, okay, you get x equals 1. Okay, that tells me that I have an exception at 1. So even though we couldn't see it on our graph, okay, you're going to have a vertical asymptote, okay, through positive 1. So my domain is the set of x values such that x does not equal 1. Now, here's what's nice. I'm going to ask you to do vertical asymptotes first here. Here's what's nice about that. Anywhere you have an exception, you have a vertical asymptote. Okay, so if x can't equal 1 here, then x must equal 1 here. If there's no exceptions to your domain, then there are no vertical asymptotes. Okay, that's not going to happen much on these, but that's what's happening here. Okay, on the horizontal asymptote side of things, okay, here's how you look at that. Okay, notice your original problem. Okay, this numerator has a degree of 5. This has a degree of 3. When the degree of the numerator is greater than the degree of denominator, there is no horizontal asymptote. Okay? When the top is bigger than the bottom, there is no horizontal asymptote. Okay? When the bottom is bigger than the top, okay, then we have a horizontal asymptote on the y-axis, or on the x-axis, sorry. So it's y equals 0. Okay, but for this one, it's none. Okay, now on number 30, 6x squared plus 6, again, start out with the domain. So 3x squared minus 5x minus 2 equals 0. Okay, this time I have to use the AC method. Okay, the AC method. So if I multiply 3 and negative 2 together, you get negative 6. And the factors of negative 6 that add to negative 5 would be negative 6 and 1. So 3x squared minus 6x plus 1x minus 2. Okay, I'm going to factor a 3x out of the first two terms. That leaves x minus 2. I'm going to factor a 1 out of the last two. That's x minus 2 again. So I get 3x plus 1 and x minus 2 as my two expressions. And then from there, I want to set each one of those equal to 0. So x equals negative 1/3 when I solve this for x. And then x equals 2, okay, when I solve this one for x. And then expressing that in terms of my domain. So my domain is the set of x values such that x does not equal negative 1/3 and 2. Okay? Again, second part, so that's your domain, part A. Okay? Part B, vertical asymptotes, x equals negative 1/3 and x equals 2. And then lastly, horizontal asymptotes. Again, note the degree. The degree of the top is 2. the degree on the bottom is 2. When the degree of both your numerator and denominator are the same, then you take the leading coefficients, the coefficients in front of those terms, create a fraction, and reduce it. Okay, so in this case, I'm going to take the 6 here and the 3 here. And if you reduce that down, 6 over 3 is 2. So I have vertical asymptotes at -1/3 and 2. And then I have a horizontal asymptote at, oops, sorry, it'd be nice if you could see that, wouldn't it? Okay, so the horizontal asymptote, using these numbers up here, 6 over 3, you get y equals 2. Okay, so you just have one problem in that group to finish. You'll do it a lot like 28 is a lot like 30. Okay, but in some regards simpler. That should give you the information that you need to finish that first worksheet. Give me a holler if you're still having concerns about any parts of it, and then I'll try to help you from there. Okay, the worksheet 8, I will start posting videos for it soon, but I don't, this will be one that, if you turn it in Thursday, great. However, this one probably won't be turned in. 7 will not be turned in until next week, and I'm fine with that. Okay? Okay, thank you.